Hey everybody, this is Mr. Beckstrom, and today I want to take a look at number 9 from section 8.3. This was asked in the forums here, and it says a cruise ship maintains a speed of 8 knots, or 8 nautical miles per hour, sailing from San Juan to Barbados, a distance of 600 nautical miles. To avoid a tropical storm, the captain heads out of San Juan at a direction of 13 degrees off a direct heading to Barbados. The captain maintains the 8-knot speed for 12 hours, after which time the path to Barbados becomes clear of storms. It's a two-part question. The first part says, through what angle should the captain turn to head directly to Barbados? So at which point should he turn to go to Barbados, or which angle? And then once the turn is made, how long will it be before the ship reaches Barbados if the same 8-knot speed is maintained? All right, let's go ahead and set this up here. Okay, so I'm going to go ahead and draw just kind of an arbitrary triangle that looks similar to this without moving my whole screen around. And hopefully it will take shape. There we go. Turn that back off. And I'm going to go ahead and label my triangle. So I'll call this A. Call them whatever you want. Just make sure that you call the corresponding sides by the same letters as the angles. So the opposite side of big A will be little a. The opposite side of big C will be little c. The opposite side of big B will be little b. I know that this here is 13 degrees. I know this side over here is 600. And we can pretty easily find out what this distance is here, because we know we're going 8 miles per hour for 12 hours. So 8 miles an hour for 12 hours, we just really multiply 8 miles times 12 hours. So 8 times 12 should be 96. You know, I never learned my 12s, but I think I pretty much know them by now. So this here should be equal to 96. I'm just going to write that down over there. All right. And let me just make sure I haven't forgotten anything in here. So now we have a triangle where we know a side, an included angle, and a side. So this is a side, angle, side triangle. And we know with the side, angle, side, and the side, side, those two, we need to start with the law of cosines. And with the law of cosine, since we know B and C, then we're going to use out of the 3 formulas, we're going to use the one that starts with the A squared. So that means that it's going to look like this formula here. So A squared. So we're going to have to solve for A first. Even though we really want to know this angle here, C, we really need to solve for this variable first. So A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of big A. So that's the formula we're going to use because we know B and C. If we were trying to solve for C, then we would start with C squared. And this would be A squared plus B squared. So there's 3 of them we could use, but this is the one that we use. All right, so let's go ahead and plug in our value. So A squared is going to be equal to B squared, so that's 96 squared plus 600 squared. 600 squared minus 2 times 96, right, times 600 times the cosine of 13 degrees. 13 degrees. All right. Now we're just going to put this in our calculator. Okay, so and then we have to take the square root of both sides. So first I'm going to stick it in here. So we have 96. Oh, let me make sure I'm in the correct mode. We should be in degrees. Don't forget to double check that. So 96 squared plus 600 squared minus 2 times 96 times 600 times the cosine of 13 degrees times the cosine of 13 degrees, and we get a huge number. Then we take the square root of both sides. I'm going to do second square root of second, my last answer, and I get about 506.9. So A is approximately, to one decimal point, 6.9. All right, so I'll write this 506.9. Now remember, angles are kind of relatively the same size as their opposite sides here. So if 13 degrees is 506, and we have 600 over here, C should be a bit bigger than 13 degrees, but it's not going to be super huge, right? So we should be expecting some angle bigger than 13 degrees, decently bigger. All right, so let's go ahead and use the law of sines to figure out what C is, because we need to use that because we only have one of the angles so far, but now we have those two sides. So we're going to use law of sines. So let's do that over here. So now I have the sine of 13 all over 506.9. 506.9 is equal to, and we're trying to find that, the sine of C all over 600. 600. Okay, and then we're going to go ahead, cross multiply, divide. So you're going to get the sine of C is going to be equal to 600 times the sine of 13 degrees all over 506.9. Hopefully we used enough decimal points in this. So C should be the inverse sine of that whole thing. I hate writing that in, but it's hard with the mouse. I'm trying to get a Surface Book, but they are expensive. 0.9, and let's see what we get when we do that. All right, so 6, oops, clear. So inverse sine of, I want to put the top in, it'll do it in the correct order of operations. So 600 times the sine of 13, close parentheses, divided by 506.9. All right, that looks correct. And I'm going to get 15.44. So rounded to one decimal place, that's going to be 15.4 degrees. 15.4. Now remember, when we do the inverse sine, we also have to consider 180 minus that 15.4, which is 164.6. Now if that was 164.6 and you added that 13 there, plus 13, that means that this last angle here would have to be 3 degrees. So you could technically have two triangles here. However, these two sides are pretty close to the same length. So to have these two angles here be that far off, the same two opposite angles be that far off wouldn't make any sense. So that's how we know. Since these two sides are pretty close, their corresponding angles should be relatively close as well. So the 15.4 degrees is going to be the correct one here. And that's the best way I know in order to kind of know which one of those to use. All right. There's probably a better way, and I'll take a look at that. But it's usually I kind of look at the corresponding opposite angles there. All right, so 15.4 is that, and then we're gonna. So that is the first part of that answer, degrees, and then the second part is once the turn is made, how long will it take before the ship reaches Barbados if the same 8 nautical miles is maintained. So we're going 8 nautical miles, and we're going that for 506.9 miles. So let's find that out. Okay, so in the beginning, in order to find out how long it took to get from A to C, what we did was we just multiplied our speed here by 12 in order to get that amount. So the easiest way to see how long it's going to take from C to B, we can just really just divide our distance here by the number of miles per hour, 8. So if we just take our distance here, because we went 506.9 miles, and really we can kind of set that up as a unit fraction. So if I went 506.9 miles, and I can say that's times, and my speed is 8 miles for every 1 hour, right? So I'll put the 8 miles down here, miles every 1 hour. And those will cancel out, and then I'm just left with 506.9 divided by 8, and that should tell me the number of hours. So 506.9 divided by 8, and I get 63.4. So this is approximately 63.4 hours to get from this point here to that point there. And so let me put this in here, 15.4, 15.4. We can pretty easily find this angle. That's going to be a huge angle, right? But the question didn't even ask for that. All right. Hopefully this helps. If you have any questions, let me know. And I hope you all have a great rest of your Monday. And good luck on the test tomorrow. Thanks.